So, Krishnamurthy, great presentation. For use case one, you mentioned network packet broker, software-based app. Traditionally, we have seen that this use case was handled by a hardware tap solution, right? And it's CPU intensive use case. Um, I wanted to understand, have you tested software tab for a real environment? How's the performance shaping up? Are there any concerns and challenges there? And then I have a follow-up question to that, so I'll let you respond to that first.
Yeah, so we have done two pre-trials with two of the customers where the number that I was talking about, right? Let's say you can filter a set of traffic and then, selectively forward only part of traffic onto the monitoring tool, right? That filter number we have tested till 2000 such filters in the hardware. So this was with the Broadcom XGS ASIC. We do see that, when it comes to the hardware performance, there may be, obviously when the moment we completely deal with software, there may be few hookups, but the point that we are trying to address is for a typical small to medium scale enterprise, right? Compare the cost of buying a hardware tab with the SONiC based software, right? So that's where the customer is still okay for his kind of deployment. He can still try to afford to buy only software tab and live with it. And also the moment we say a functionality is implemented in software, of course, there are areas for bugs or improvement, but the kind of flexibility it offers to the user in terms of as simple as saying the number of packets filter, show command related to that, or you put a few kind of network management solution on top of that to display him what exactly happening is live, right? The flexibility when it comes to software solution is also more. So to answer your question, yes, we have tested till about 2000 filters in the hardware and the performance is decent enough.
Okay. Follow-up question. So the packet broker solution that you have, is that a homegrown solution or you're basing it off open source tool like Archimey or something like that?
It's a homegrown solution where we have kind of added extra set of developed code on top of SONiC based nodes. It's a homegrown solution.
Got it. And then for the monitoring aspect of things, what are some of the solutions that you might have tested?
So we have tested with the integration of Grafana and Prometheus server. But having said that, we are under POC stage for one of the enormous solution of our own actually. So what we are seeing is typically this extends to the next set of deployment now, right? The moment you have a data center, you selectively pick up a set of traffic, put it onto some network management tool, right? What next is some kind of analytics with it. So the idea behind developing a typical analytics software and how much sort of flexibility when it comes to monitoring and visualization that we can offer to the customer as a bundle along with filtering plus dashboard capabilities, right? That is what we are attempting now.
Got it. Last question. For the network packet broker capability, have you leveraged any of the inherent SONiC capabilities like Everflow or any of that?
So basically we are using some kind of ACLs because that's one of the major reasons, right? At least for a small to medium scale deployments, we might not have to completely depend on SAI because SAI is not that rich. But if you see from where we are standing today, the ACL capability which is present in SONiC is powerful enough to serve this kind of deployment.
Got it. Thank you.
Hello. Yeah, so I was asking that this network packet broker solution, is this a new hop in the middle or is it like they have an existing infrastructure like this Broadcom hardwares where you are running this? Because introducing one more hop in between, like then again, there are different problems of redundancy and other stuff that come into picture, right?
So we can combine it in both the ways, but what we have presently is an out of band solution. So which is a new hop in between, but like I explained with regard to the lag and the bundling of traffic aggregation, right? With that, the benefits that you are getting is powerful enough for you to compensate with this new hop.
And so for these kind of solutions, one other thing that, for example, we are talking with Arista is like, so there are container-based solutions, for example, which can emulate some kind of thing like streaming telemetry and some kind of these flow controls and basically flow monitoring, those kind of solutions. So why not run some lightweight containers on the routers rather than have a centralized solution where you do all of these things?
So we can do it either ways actually, but generally what happens is if you're it's got something to do with your software design also. Now let's say with what as the base have we built our packet broker solution, right? Now if I have based it out of something out of ACL which is running in SONiC, and if you're trying to deploy a new container in the existing network, the typical BGP or some other protocols running in the network already might mess up with your packet filtering capabilities itself. That's where till date we have tried to put it as a out of band. So for in band, we need to think what exactly better can be done.
Thank you.
So yeah, thank you very much everyone. Yeah.
I have one question. This is Partha from Broadcom.
Sure.
So regarding the security, right? We are collecting packets. So this security solution, is this going to predict kind of intrusion detections, or some kind of malicious activities going on the network? Is it going to predict that based on the packet pattern?
So exactly, that is the idea. This part of product line is something which we are still investigating, and to be honest, we haven't put much thought into it. But the idea is one of the key feature or the key use case of network packet broker is collect a set of data, and that sample set of data, right? It's used as a input for an analytics engine, which has a feedback mechanism for doing a predictive analysis, and both the IDS and IPSing, both intrusion detection system as well as the intrusion prevention system, what you're talking of, right? So that comes as part of the analytics. Sure.
The second question on the forensic, I just like to understand. Maybe it's mainly done from the IoT perspective, or okay, even it is a generic. How do you know what data has to be kept? Is there any kind of algorithms that you are running? Because in a forensic, you really have to preserve the data that are important for your later on investigations.
Correct,
so how do you categorize those data in the forensic?
So yeah, I think again the main point is, see, this is something which we have absolutely not done now. The kind of software we have developed here, the use cases for deploying that software are these two. But just to touch upon this question, right? So what actually they say is, from our research, you can try to put some kind of install some filters in hardware during some times of the day to see any malicious kind of traffics are actually entering the system. And that data, when I collect, parse it, and send out to some kind of agent here, right? This agent should be capable enough to make sense out of data and then act upon that data. So that's the overall idea. But this, whatever the act upon the filtered set of data, right? That is something which we have not done.
Okay, so also I think you are talking about some of the ML applications that you will be probably employing some of the machine learning over the data that you are collecting from the switches, right? And that's what you are going to do, right?
Yes.
Okay. Okay. Thank you.
So the usage of the filtered data into a big analytics application, right? That is the next step. Yes.
Thanks a lot. Thank you.
Thank you.